So now that we know a few basic terms, we're going to start learning about what we call scalars and vectors, which were briefly mentioned earlier, but we didn't really talk about it a whole lot when we were talking about forces. So first of all, let's remind ourselves about units. So there are a number of internationally accepted units of measurement. This is the SI units, or International System of Units. And you have this table in your packet on the note page that you were working on the last video. And I have left a few of them for you to actually write in. These are the ones that you really need to know. I've highlighted them in this like orangey color. So the base unit for length is a meter and the symbol is an M. The base unit for mass is a kilogram and it's kg. Notice this is kilogram, it is not gram. And time, the base unit is second, and that's normally abbreviated as an S. These other items, we'll talk a little bit more about temperature when we're in chemistry, and you'll talk about moles in chemistry. We won't do a whole lot with electric current or luminous intensity. So the three that you need to know as of now are the base units for length, mass, and time. So mark those in your note sheet that those are the ones that you need to learn. And then talking about scalars and vectors, a scalar is a quantity that has magnitude or size only, but no direction. So things like kilometers per hour, meters per second, kilograms, degrees Fahrenheit. Vector quantities have both magnitude and direction, and the direction is usually given in square brackets after the units. So you would say that something was traveling at 15 kilometers per hour west, and you'd put the west in the square brackets. You would also could use meters per second squared, and you can use something like north by 23 degrees west. You can have forward, you can have backwards, you can have left, you can have right. But you need to have some sort of direction with vectors. So for vectors, I want to play a really short video from Despicable Me.
Hey. I'm applying for a new villain loan. Go by the name of Vector. It's a mathematical term, a quantity represented by an arrow with both direction and magnitude. Vector! That's me, as I'm committing crimes with both direction and magnitude. Oh yeah! Check out my new weapon. Piranha gun! Oh yes! Fires live piranhas. Never seen one before? No, you haven't. I invented it. You want a demonstration? Oh, Christ, it's so difficult sometimes to get blind eyes.
Mr. Perkins, you see that? So you may have seen the video, but never really recognized that they were talking about a physics concept. So maybe that'll be helpful to you to remember the concept of vector. So let's check and see if you kind of grasp this idea of which is a scalar and which is a vector. So we've got a couple of items here. So take a moment, pause the video, identify which of these you think are vectors and which you think are scalars. So looking at these, the ones that have units and then that are followed by a direction and a bracket are the vectors. So we've got 9 milliseconds is a scalar, 3.1 meters up is a vector, 15 centimeters squared is a scalar, 500 hertz is a scalar, 113 kilometers per hour west is a vector, and 50 milliliters is a scalar. So I noticed that I had that the vector on a different line, so I have fixed it. So again, the one with the west is a vector and the one with no direction is a scalar. So also in your packet, you have a doodle note sheet, which I'm going to go through and have you copy all the information down. So your doodle note sheet is on Yellow Packet page 5. So up at the top, it talks about the scalars, and the definition is a scalar has only a magnitude and no direction. Magnitude is a value, it's a number. So there's some examples over here. We've got a thermometer measuring temperature. We've got this block that has height, width, and length. And we've got examples of 1.5 kilograms, 2.3 centimeters, 29 degrees C, on 100 calories. And notice none of these have directions. Whereas the vector quantities have direction. And the definition is a vector quantity has both a magnitude and a direction. So it has a number part and a direction part. So in vector notation, we write things with a magnitude, a unit, and a direction. So you see the examples here of 25 kilometers, and then the square brackets of north 10 degrees west, and then they close the brackets. So you determine direction normally with a compass, with north, south, east, and west. But we will also be using things like left and right and forwards and backwards, and so we won't normally have things with degrees. So spring scales measure force in a certain direction, and this is the kind of device that we use to actually measure force. It's a spring here. We have some in school. If I'm back with you, I will show that to you. And so what I'd like you to do is take a moment and identify which of the following units below here are designating vectors. So pause the video for a moment, and then you can take a look at the answers. So I've identified here all of the things that are vectors, and they were highlighted with purple. So one last thing we're going to do before we wrap up this topic. So on the page 6, describing motion verbally with distance and displacement, we're going to just do this top part that says vectors versus scalars. So most of the quantities that are used to describe motion can be categorized as either vectors or scalars, and it gives you the definitions. And we care about these terms that are listed here. And as of right now, we don't know what all of them are, but we're going to go ahead and fill in the table anyway. So distance is a scalar and displacement is a vector. Speed is a scalar and velocity is a vector. Acceleration is also a vector. And we've already been studying forces, and those are also vectors. And if you didn't catch that, it'll be on the next slide, so it's okay. Number 2 and 3, you should be able to answer both of those right now. So number 2, a quantity that's ignorant of direction is referred to as a scalar. And number 3, a quantity that's conscious of direction is referred to as a vector. So here are those ones again. So scalars include distance and speed, and vectors include displacement, velocity, acceleration, and one other one that I'd like you to write in is force. So what I'd like you to do now for follow-up work is to work in your MOP app, and you're going to be in part 1 this time. You're going to do KC1. KC stands for kinematic concepts, and it is number 1, and it's going to be on vectors and scalars. So there's an additional reading that goes along with this. If you feel like after you've answered some of these questions that you need a little bit of help, take a look at this resource on Physics Classroom about scalars and vectors. Typically, this is a pretty easy one, and most students don't have a lot of issues. So contact me with any questions if you get stuck. Otherwise, you're going to just need to provide me with your code, and I will be back with you on the next video.